In this session we're going to talk about computer hardware for CAD. This is part 1 of 8 and this builds up the knowledge that you will need for the City and Guilds level 3 CAD systems test that you will have to do as part of your course. I appreciate some of you will not know any of this information. It'd be completely new, and likewise some of you will have quite a lot of knowledge on this. We're going to cover it in a basic level, just to give you enough information for what you need to pass this exam. At the end of this session there's a little test for you to do, a little bit of work I want you to go away and achieve. So yeah, let's jump in. So what we're going to look at in this session then is a range of computer hardware. So we're going to look at not the software that's inside that makes the computer run, but all of the hardware that works together to enable the software to operate effectively and efficiently. Why is this important for CAD? Well, because CAD's a software and it's quite an intensive software, intensive in the respect that it's going to be using lots of computer power, you really need to have an understanding of how these different peripherals work together and how you can make the best CAD system to make your computer run efficiently and effectively. Now, a lot of computers nowadays are more than capable of running SolidWorks and other high-powered software. However, you go back 5 years or so and it used to be a real pain. So having a bit of knowledge on this will be useful for you. So we're going to look at the different hardware peripherals in this session, so the things that are actually inside your computer or inside a laptop. We're going to look at how they affect the speed and efficiency of a CAD system, and that's the key couple of bits here. At the end of this session, I have 5 questions for you, which I want you to go away and write down. Write down your answers to those questions, and that's the information that you will need when we come to take the test. So first off, let's describe what a computer system is. So a computer system can be considered to be all of the different peripherals, all of the different hardware, all of the software that create a system to enable the software to run effectively, and for you as a user to be able to input things into the software and also take outputs back out of the computer. Okay, so in here we've got things like the monitors, the speakers, keyboard, mouse, printer, a host of other things as well. We're going to, as I said earlier, we're going to focus on this session purely on the things that are inside a computer. So you can see here on this image, this is the inside of a computer tower. Now, I don't know if any of you have ever taken a computer apart before. On the outside, they would seem like quite complex machines, but actually when you understand a little bit about these computers and about the peripherals, it's not that complicated. Now, I'm not saying what's inside each of these peripherals isn't highly advanced and really sophisticated, but as a basic user with a little bit of knowledge and experience, not much, anyone should be able to open up a computer or hardware, a computer or a laptop, and be able to change the hard drive. You should be able to change the RAM. And those are the 2 main things that an everyday person would look at being able to do. And a little story of this, how I started learning about computers, it's probably about 20 years ago now. I used to do lots of music on a computer, and it's really RAM intensive. So we'll explain what the RAM is a little bit later. I phoned up a computer shop and asked them if they could install some RAM into my computer to make it run more efficiently. They told me it was going to cost me £120 and it was going to take them a week to do. I drove to my nearest PC World. I purchased a stick of RAM off the shelf. It cost me £30. I went home and 10 minutes later it was installed in my computer and my computer was running. So what I'm trying to say there is that it is very easy, and these systems are built in a way to make it easy for you to upgrade and tweak and change things. Okay, so let's look in a little bit more detail now about what's in each of these, what each of these peripherals are. Look at then is the CPU. This is the central processing unit, and if I just see if I can jump back a slide, I can't jump back a slide. So the central processing unit is considered to be the brain of the computer. It's where all the calculations are made. It receives all the instructions from the hardware, all the input instructions, and it does all the calculations for the software. So you're probably aware that computers run on a binary system whereby there's zeros and ones, and there's lots of little tiny calculations going on, hundreds of thousands of calculations every second. And this is where most of that data happens, most of those calculations happen. So, why is the CPU important in a computer? Well, if you have a fast CPU, you'll be able to do your calculations faster. So a typical specification for a CPU nowadays is 2.8 gigahertz. That means that it will run at 2.8 gigacycles per second, which is an incredible speed. These microprocessors are so advanced these days that they're literally building these down to the nano scale, and all it is millions of tiny little switches, a 0 and 1 switch, and it just moves an electron from a state of 0 to a state of 1. They are really incredible pieces of electronics. That's pretty much as far as my knowledge goes on them. I know they run extremely hot, and if you ever get a fan, there's usually a fan at the back of the CPU. If that fan cuts out for a second, that processor will melt. It runs that hot. So why is that important for a CAD system? So we just mentioned that a faster CPU will enable more calculations, so it can do more things quickly. If you've got a slower CPU, then it's going to slow down that workflow a little bit. You'll also, if you know anything about computers, if you've ever looked at a specification of a computer, you'll see now that there's multi-core CPUs, and that doesn't necessarily mean that the CPU will do the calculations any quicker, but what it means is if you have a dual core CPU, it means it can process 2 streams of data or 2 threads of data at one time. A single core CPU will process 1 thread of data at once. If you get a quad core, you'll then have 4 threads of data that can be manipulated at the same time. So the processor isn't working faster, but you're enabling more information to go through the processor at any one point. Now that's really good and really important as long as the software is devised in a way that it can make use of all those multiple threads. Okay, so I've touched upon a few bits of information there, so just come back and revise this a few times. But the key thing is that a faster CPU will enable more calculations to happen quicker, which will make the CAD system more efficient. If you have a multi-core CPU, it can basically thread in more information at the same time. And I use the analogy on this of a motorway. If you've got a 2-lane motorway, you can get so much traffic through that road. If you then widen that motorway to 4 lanes, you've then got 4 lanes of information all going through that same point of the motorway at the same time. So you're able to get through many more cars, even though the cars are going at the same speed. Okay, let's jump on to the next one. Computer motherboard, or as it's commonly referred, the Mobo. lots of other names you can see on the board. If you're familiar with Apple systems, then it's also called a logic board in Apple. And basically the role of the motherboard is to connect all of the different peripherals together. The CPU that we were just talking about will sit in this area here, and this black bit that you can see on top is a heat sink, and that's to help dissipate some of that heat that we saw. Here, just coming vertically, you can see these are 2 RAM slots, and we'll look at what RAM is in a moment. And then we have these little peripheral slots down the side here, where we can connect in additional things such as hard drives, solid state drives, graphics cards, sound cards, etc. And then on board here we'll probably have some Wi-Fi. The different connectors here that you see are what you will see sticking out the front or the back of your computer, and they enable you to connect different bits of hardware to the computer. So the motherboard's job is to connect everything together, allow communication for all these different peripherals so that they can work together, and to take all of your inputs and outputs and deal with those efficiently and effectively. So the motherboard doesn't often get talked about when you look at computer hardware. However, it is a real key component to the system. I think the reason that it doesn't get talked about so much is because it's not actually performing any speed calculations, although it can create some bottlenecks in information if you have an old, slow motherboard. But generally, the peripherals that attach into the motherboard are more important than the actual motherboard itself. The motherboard makes less of an impact. So what does this mean for CAD? So when we're looking at a CAD system, what we want to ensure is that our motherboard can house and run efficiently excuse me, can run efficiently the hardware that we're plugging into it. So one of the things that I look for in a motherboard, if I'm specifically looking for one, is how many RAM slots it has and how many expansion slots that it has for additional parts. And that's pretty much it. Most motherboards these days are pretty good, so you don't really have to worry too much. Next peripheral we're going to talk about is RAM. RAM stands for Random Access Memory, and it's basically a device for short-term memory for the computer. So it holds a lot of information about the software. It holds a lot of information about the calculations that the CPU is doing. And remember, the CPU does a lot of calculations. A lot of that data then will stream into the RAM to be stored as a short-term access memory. Now, RAM is volatile in the fact that it doesn't store any information long-term. So it's only a short-term memory device. So when you power off your computer, the RAM will clear. When you boot your computer back up, the operating system will start storing bits of information in the RAM. When you open up the software, a lot of other information will get stored into the RAM, and then there's space on the RAM then for the interaction between the user and the software and the output to also be stored. If you're storing stuff in a long-term memory, which we'll look at in a second, that can be great, but where there's a lot of information stored, and potentially a terabyte's worth of information stored on one device, it just takes a fraction of a second longer for the computer to go and find that information and retrieve it, rather than storing bits of information into the RAM where it's specifically there for the things that we're currently doing. So for the software that you're running at that one point, the RAM will hold a lot of data and information rather than trying to access it from the long-term memory. So what does RAM mean for the efficiency of a CAD system. Basically, the more RAM you've got, the more short-term memory you've got, the quicker the processor can store and retrieve information from the RAM. So RAM is really important, and it's one way to speed up a computer system very quickly and very easily. Add more RAM into a system, the computer will hold more information in its short-term memory. Also, if you've got an older computer, the RAM can actually be one of the biggest issues for the computer to run efficiently. So let's make a comparison. Going back 5-10 years when we had Windows XP, Windows XP would only use, let's say, 16 megabytes of data on your RAM. Windows 10, for example, may hold 64 megabytes of data on your RAM. If you only have 64 megabytes on your old computer, the operating system will hold all of the will take up all of the RAM, and you won't have the ability to use the RAM for the software that you want to use. So this is why old computers don't run very well with newer software. Most of the time it's down to the RAM, and the RAM will cause a bottleneck of information, and it won't be able to process things quickly, and it'll start stuttering, and it'll be slow, and it'll take ages to load up, or ages to do anything from the inputs that you put in. So a good computer, a newer computer, will have lots of RAM, which will be more than enough to hold the information that the operating system needs, that the software needs, and there'll be lots of spare room for all of the calculations that the software will need to make. So I don't know if you've ever run a CAD software on an older computer. You can quite quickly run out of RAM, and on something like SolidWorks, when you're then trying to move a model or apply a feature to a model, the software starts stuttering if it hasn't got enough RAM to hold the calculations that it needs to hold. And I think probably students nowadays don't really appreciate how much the computer power we have now, how good it is. It's the same with your phone. If you're using an old phone, that old phone will probably have less RAM in it, and all the RAM is being used up for lots of other things, and then you're trying to do something you want to do, and your phone starts being slow. And again, that's caused by a bottleneck of information that you cannot get stored efficiently into the RAM for it to then to be reused when it's required. So long and short of this, RAM is a short-term memory. The more RAM you have, the more short-term memory you have, the more efficient your computer system will run. Okay, so the RAM was the short-term memory. We also have devices that hold information long-term. So we're going to look at two. The first one we're going to look at is the hard disk drive, sometimes referred to as the HDD or the storage device. It's a non-volatile device, which means that information will be stored onto the device and it will be kept, and it's actually sat on that device. Now, if you look over to the image here, you'll see this big disk, and you'll actually see there are multiple disks, and on this one I believe there are 3. This big disk is essentially very similar to a CD. You've got this arm, this read-write arm. Let me just delete some of these other bits off here. You've got this read-write arm here, and on the tip of this is the head, so it looks very much like a vinyl arm and needle. And this head, the disk spins, the head moves, and then it reads the data that's stored on the disk, or it writes the data onto the disk in a certain place. And these disks, as I said, can be multi-layered. So they're really good. The key thing with the hard drive is that the speed that the hard drive can store and retrieve information is really important. So when you switch a computer on, you can sometimes hear a little whirling going on, and that whirling can often be from the hard disk. It's booting up this disk, it's spinning, it's then reading the information that it needs, sending the information back out into the computer. Now, because this is a mechanical device, you've got lots of moving parts, and this arm's physically got to move in and out and find the data that it needs and then send that to the computer. So although these hard drives are really sophisticated pieces of kit, they're not necessarily the most efficient way of storing and retrieving data. Now, the next one that we'll look at will explain where the advancement has now came. So the long and short of computer HDD is basically that it is a physical device that reads and stores data physically on these magnetic disks. How does that affect the speed and efficiency of a CAD system? Well, if you're retrieving data or you're needing to save information, or even loading the software, because the software will be installed on this disk as well, the information for the software, you've got this slight delay because of all these physical, mechanical processes happening before it can pull the data in and out. So a hard drive can slow a computer down slightly compared to the new method, which we'll look at next. Obviously you need the hard drive to be able to store enough information, and this then can affect the CAD system. This can affect the CAD system if you're saving lots of information and lots of data. Doesn't have a massive effect on a CAD system, in all honesty. You can use quite an old hard drive as long as there's enough space for you to store the software and to store some information. You're talking very small amounts of very small effects on the actual running of the CAD system, but it's still important to know. Okay, so nowadays we have solid state drives, very similar to a flash drive, a flash USB drive that most people have and use. It's basically a storage device that contains lots of memory chips. It's non-volatile, which means the information will stay on that disk until it is physically taken off. So the big difference between a solid state drive and a hard disk drive is that the solid state drive has 0 mechanical parts within it. There is nothing that moves. It's simply a circuit board with rows of memory chips to store the information. So you have no moving parts, no physical moving parts, which means that your read and write times are much quicker, much more efficient. There's no noise for the operation. Because there are no mechanical parts, the reliability is improved and it requires less power to use. So perfect for a laptop where you're not plugging in all of the time. Your computer will then run for longer because it's not having to move all these physical things inside the hard drive. So again, what does this mean for a CAD system? If you have a solid state drive, the speed of read and write will improve, which will mean that the computer will run a little bit more efficiently. Now, I said before that the hard drive doesn't make a massive difference. However, a very recent experience of mine has actually shown me just how much the effect of the solid state drive can have. So tiny little story of an experience I had quite recently. I've got an all-in-one computer which is about 4 or 5 years old now, and I was having problems with the computer's speed. So when I started the computer up, it was taking 2 to 3 minutes before the computer was actually ready to do anything, before it was responsive. And then sometimes some of the software was working slowly. You'd click on a button to open up Google and it would take 20 seconds for Google to open up. So I decided that I was going to replace the hard drive in it because I wanted to reboot all the software up. So with all those mechanical parts within the hard drive, the hard disk drive, I thought potentially if I put a solid state drive in, it might improve a little bit, because 5-year-old mechanical device being used quite substantially, potentially there's going to be some wear and potentially it's not going to work as well as it could. So I changed the solid state drive. Very simple. I opened the computer up, I found the hard drive, I took a couple of screws out and then literally pulled this connector apart, and the hard drive was in my hand, and then I put the new one in, physically just pushed these connectors into the right place into the motherboard, and then screwed the solid state drive back in, reinstalled Windows, reinstalled some of the software that I wanted, and I was actually amazed by how much of a difference this solid state drive made to the efficiency of that system. So I said before you were looking at 2 to 3 minutes at least for the computer to start being responsive. I put this solid state drive in and I timed it at 14 seconds between the time I switched the computer on to the time that the software was responsive and I could actually use the computer. So it made a massive difference. So if you've got a computer that's taking longer than it should do to open up the software and to be responsive, then maybe the solid state drive is something that needs to be looked at. If your computer is stuttering a little bit as you're using it, then I would say that's more of a RAM issue. Okay, so long and short, why is that really effective for a CAD system? It means it will store and retrieve data much quicker. Often these solid state drives now are much bigger in size than, not physically, but they can hold more data than a hard disk drive. And for me, I want to be able to turn my computer on and do what I need to do without having any delays. So from a user perspective, that extra little bit of speed just to get the software going can make all the difference to my experience. The thing we're going to discuss is the graphics card. Now, most motherboards will have a graphics card inbuilt. Those graphics cards that are inbuilt are there to be able to process the visual information to give you a visual output. Without a graphics card or without a graphics processing unit on board a motherboard, the motherboard wouldn't be able to give any display. So every single motherboard and every single computer has a graphics card. However, if you're using graphic intensive software such as CAD, such as audio or visual processing software, such as gaming, so anything where the graphics are really intensive and are changing a lot and have a lot of dynamic to them, it's often advisable that you get a separate hardware peripheral, a separate hardware graphics card. So this is an extra device that isn't part of the motherboard. So actually on the laptop that I'm using to record this, I have a graphics card, and I also have the onboard graphics on my motherboard, and I can select between the two which I want to use. I tend to use the additional graphics card I have for everything, because it gives me a better resolution on my screen, and it gives me more options for what I can do. Now, the big power of this is where having this additional graphics card will have its own CPU and it will have its own RAM on the actual graphics card. So that is really important. So when I'm using CAD systems, the software can direct the graphic information that it needs to process and store and retrieve directly to the graphics card, which means that those processes don't take place on my main CPU and on my RAM. The benefit of that is that the CPU and the RAM will have more space to do other processes, and the graphics card can handle all of the graphic information. Okay, so if you're building things with lots and lots of parts in SolidWorks or in another CAD software, you may start getting some stuttering where the processor and the RAM can't do all the calculations for you quick enough. So if you add a graphics card into that system, then the graphics card will take all of that processing away from your main CPU and your main RAM. So the key takeaway is that the graphics card isn't an essential. However, it will make things run more efficiently and make the speed of your system better by taking away a bulk of the processes that it needs to run away from the main CPU and RAM, and it will process it on its onboard hardware. A bit of hardware we're going to discuss is the VDU, which is the video display unit, or the monitor as everyone knows it by. So the monitor is there to give you a visual output from the computer. Sometimes nowadays it can also be an input device with the touchscreen monitors that we have now. The screen size of the monitor is really important because the bigger the monitor that you have, the more information you can have on the screen at any one point. With software such as CAD and SolidWorks that we've used, there's lots of buttons, lots of things that you want on the screen, which then limits the space that you've got to actually do your modeling. It may limit you to having just one or two views of the model as you're working. You may not be able to see other documents, other sketches, or have information from other people. So the bigger screen size that you have, obviously the more information and documentation you can have on the screen at one point, which can help significantly when you're trying to do lots of different things at the same time. The resolution of the computer is also very important, and the resolution is basically how fine the detail is on the screen. Some older computers and some older monitors, the resolution may not be that high, which then means you get a little bit of fuzziness on the screen, and that can cause visual tiredness, which means that you can't use the system quite as much as you would like. When we're looking at software with lots of detail like CAD, and you want to be able to see all the little bits of detail, any slight tweaks or changes, the computer resolution will have a huge impact on that. So, key takeaway for the VDU is that the screen size is important, because the smaller the screen, the less information you can see, the less clearly things are. The resolution is important because it can affect the amount of time that you could use the computer, but it also affects the amount of detail that you can see at any one point. And things can appear a little bit fuzzy, etc. So a very quick way to increase your screen size would be to add a second monitor, which is what quite a few people do, and especially people in CAD circles. You'll usually have two monitors. You'll have one for doing your modeling on, which will often be a HD unit with quite a big resolution, and then I would always have a second monitor which I could have design notes, drawings, communications with other people, other models open up on that screen that I'm needing to consider as I make something else. So the key thing here to remember then is the screen size is important. You want a big screen to get lots of information on the screen, have more modeling space as well, and the resolution to make sure everything is that much clearer so that you can use the system more effectively and efficiently in the long term. Okay, so we've looked at all those different hardware peripherals. We're going to look at more as we go through the rest of this course, but we've just looked at what's inside the computer. So it's really important for you to be able to link that into why that's important for CAD. So the computer system and the hardware will dramatically affect the performance of a CAD software. So if you've got a low specification computer with a slow CPU, not much RAM, a slow motherboard, it will often cause lots of stutters to the software. It will cause crashes. It will cause a slow workflow. For me, those are the worst three things that I can have. And sometimes even on a well-spec computer, a modern computer, those things can happen. The user experience then is diminished somewhat, and I get quite frustrated when that happens. Best thing to do at that point, make sure all your work is saved, switch your computer off, let it reboot. That will clear your RAM, open all the RAM back up, and if there's any programs that are causing that stuttering, they will also be closed, so you can then refocus back on what you're doing. I think people nowadays don't really have too many issues with low spec computers. Most computers that we have are pretty efficient in running things, especially if they're a year or 2 years old. Once you get a little bit further beyond that, the efficiency does slow down a little bit. So just be mindful of that. You go to the opposite end of a spectrum, you have a very high specification computer. Those can be extremely expensive. I saw what looked to be a very interesting CAD laptop in a magazine that I was looking at, and I thought, wow, that looks really good as a CAD computer, and I thought, that's going to be a couple of £1,000 to buy. I went onto the website. It was a Dell computer. It was £22,000. It had all of the latest hardware that you could basically have in that computer. Now, for specific needs, that would be required, and people will spend that money to buy those types of computers. But you don't need that necessarily for everyday things. But everything comes down to what you need and what you can afford. There's a good balance. Get good balance. Make sure when you're speccing up a computer system, you've got more than enough for what you need now, because the software will develop over a couple of years. I always try and think what I need now, and then try to add on at least 20 or 30% on top of that, but trying to work within the budget that you have for a computer. Okay, so look at some computer hardware for a typical CAD system. So we've been using SolidWorks, and this is straight off the SolidWorks website. So the first thing to really note is that SolidWorks is only available for a PC desktop. So it doesn't work on Mac as standard. There are ways that you can get Windows software to work on Mac. You lose a bit of the efficiency, but it is possible, and I have seen it done. But as standard, SolidWorks is only designed to run on a PC desktop. So just want to clarify that. So a desktop is usually a tower computer and a separate monitor. I run SolidWorks quite happily off a laptop, not a problem at all. I've seen SolidWorks run on tablets as well, although it does need to be quite a good tablet. I saw a Surface Pro 3, which is a a 12-inch touchscreen laptop, so probably quite similar to a newer iPad, and it ran very well on that system. So let's just have a quick look at what it says you need to run SolidWorks. So a 3.3 gigahertz processor or higher. This states these are minimum system requirements. I'm not sure on that. The laptop that I'm running is a 2.8 gigahertz laptop, and it runs perfectly well. And there's a tool in SolidWorks where you can test it to see how many parts it believes you can run. And when I ran it on the laptop that I'm using now, it came back and said that I could run over 12,000 parts concurrently. So 3.3 gigahertz processor, I think you can probably go down to probably at a 2.4 gigahertz processor. Operating system, so Windows 10 64-bit. We haven't really talked about operating systems too much. It's basically the software that runs the computer, so all the software needs to be compatible with your operating system. 64-bit, that's basically the size of the binary digit that the computer can hold, so the higher that is, the more detail and information you can get running on the computer at any one point. So an easy way to kind of describe that, I suppose, is the amount of colors that you would have available. So there could be on a 64-bit system, you will have millions and millions of colors available. If you go down to a 2-bit system, you would either have black or white, and that would be it. So there's only 2 colors available. Okay, very generalized, but I'm just trying to give you some way to understand what the bits are. Okay, so memory, so 16 gigabytes or more of memory, so that is the RAM. And yes, I agree with that. It will run a lot lower than that, but 16 gigabytes will give you a good user experience. So 16 gigabytes of short-term memory. A hard drive, it recommends a solid state drive. That's best for performance. However, as I said before, any hard drive that will store the software, and I think the software is about 8 gigabytes in size, have room to store stuff, that will actually be fine as well. So it's not a massive issue for the hard drive. Graphics card, the best card you can have for your system. So that comes down to cost. Any separated graphics card is going to give you a marked improvement in performance on the onboard graphics on your motherboard. So basically what it's saying is just whatever graphics card you can get for your budget, then get it. A couple of years ago I bought some CAD computers for a college, and we spent nearly half of the budget on the graphics card to go inside the computer. So I think we spent about £600 on a graphics card, and then the rest of the CAD system was about £600 as well, because it made that much of a difference. SolidWorks also needs you to have Excel and Word. Lots of things in SolidWorks actually uses little Excel tables and Excel data, so you need to have those installed. Again, that's more of a recommendation. And finally, having an antivirus software, that's required for pretty much anything these days for any computer system that's running. One thing that I don't skimp on is the antivirus, because it does end up saving you lots of time and effort in the long run. Okay, next thing, I'm going to post the link to this video below here as well. If you're not watching this on YouTube, then which is where I'm intending to post this, do a search for the best PC and laptop hardware specifications for SolidWorks. There's a great little video which I want you to just watch, and it's from SolidWorks, and I'll talk about some of these hardware in specific terms for SolidWorks, probably describe things a little bit differently to how I've just done it here. Fully equipped with all the information that you'll need to answer these 5 questions I've put up on the screen. The key thing with these is that you need to look at how the peripheral affects the speed and the efficiency of a CAD system. So I want you to write 40 words on each of these, which is 2 or 3 sentences. Make sure that you understand it in your head. Make sure you understand what each of these bits are, because these will be key things when it comes to your your test that you will do for CAD. Okay, and also really good information for you to, really good knowledge for you to have as you go forward. You know, people buy computers all the time these days, and if you ever want to go and buy a computer, you'll have a little bit of an understanding of what these are. So what I find is that sometimes the ads for computer systems focus on things that aren't important. So having a little bit of knowledge will enable you to make a more informed choice. Okay, good luck.